understand, by the way, that you guys are still waiting for your scores on the Scantron. So that's coming up. So yeah, so I'll go ahead and get that done this week. Okay, so and then also I need to go and get caught up with your grades as well. I should have done that during spring break. Okay, but I'll do it this week as well. And let's see here. So what physics that we are supposed to go into? What? 10.2? 10.2. Look at that. Oh, so good. 10.2. All right. So 10.2. Is that it? Right there? So, you know, as you well remember, we talked about joins. And a join is a way of bringing all these tables together. And we have this kind of thing called natural join, in which all the common columns, they bind together, right? And then you're able to go and display all this information that had been bound together by the common columns. Now, you could also go in and use this other syntax, okay? And that sort of makes it a join possible. So what if the column names are not the same? Then you can actually go ahead and just bind it manually yourself. So you could just list out the name of the tables, and then you would just go ahead and just equate all these different column names. Now, also we understand that because we're going to go ahead and just take all of these column names and prefix it with a table name, because sometimes they may be the same, and so we need to go prefix it. And it becomes a little arduous to go ahead and repeat the table name each and every single time. And so it's nice to have an alias be associated with the table. And so take a look at this one right here. So here we're looking at the three tables, patient, disease, and patient disease. And notice how we just did a natural join. And it doesn't matter when you do a natural join, what the order is, it knows how to go ahead and just bring everything together. And once again, the order does not matter. And so there is that. And then let's go over here. So imagine as if we have these three tables. And I think this all looks familiar, but anyway, so we have column A, column B, column C in table A, and then we have table B, which has column D, column B, and column A. So notice column B and column A match up with the column B and the column A there. So look at that, we have 1, 1, that matches up, we have 3, 3, that matches up, and that's really pretty much it. So when I go ahead and do a natural join, it knows that it's supposed to go and match up column B with column B there, and column A with the column B that's on the table. And so notice what happens. We come up with 1, 1, 1, 6, and that's because of that 6 right there. And it knows to not go ahead and repeat any of the column names when you do a natural join. Because you don't want to see column A from this table and column A from the other table. It contains the exact same information. And so that's what we have. And then here, we're looking at F name, coming up with a name that's called first name. Then count asterisk, so there's some grouping that's going on here. Notice this is not inside of a group function, so this means that we need to go ahead and take this F name and put it in a group by first name. Now, is this okay? Group by first name, do you like that? Is that good?
No.
No.
You have to group it by F name.
By F name, that's right. Okay, so this should be F name. So any of you folks may want to make that correction. And although it does, go ahead and, although am I saying that this is an error? Oh, I guess I am saying it's an error, so maybe you don't have to do the correction because I'm telling you that's an error. And then here, notice I'm saying having disease count greater than 1. Disease count is once again the alias associated with this count asterisk. And whenever you want to go into this having, you have to use the actual syntax here, like count asterisk greater than 1. You cannot use the aliases. And of course, we're using P, PD, and we're using the P and the PD to go ahead and refer to the various tables. And here I go and show you the correction in which we have a group by F name, and then having count asterisk greater than 1. So keep that in mind. Okay. Now, let's go ahead and take a look at this. Now, this is a joint as well, but it's a non-equi joint, okay? And the reason why they refer to it as a non-equi joint is because the columns are not matching up exactly, okay? So let's find out what it's going on. Imagine as if you have these students. And then you've identified this table called grade range. So anyone who is between a 90 and a 100 gets an A, 80 and 89 is a B, so on and so forth. So by the way, that's the column name right there. And this is the beginning score, ending score, there's the grade. Okay. So that's what we have. And so we go ahead and do, so we'd like to go ahead and display the following. That Jack, who has an 80, is getting a B. And Scott, who's got a 73, is getting a C. So we'd like to go ahead and just get information from both of these tables. So in this scenario, once again, we go ahead and identify the students and the grades table, okay? So there's the two tables. And then we have the where. Now, you notice that this score right here doesn't match up with any one of these columns. It has to go ahead and deal with the range that we're looking at. And that's why it's a non-equi joint, because we're still trying to go and match it up with a row on the other side. But it doesn't, it's not a one-to-one match of a column with one column here. So look at how we do it. We say our score is between the beginning score and the end score. So when we're looking at this, is that 80? Is it within this range, 90 and 100? No. Is it between 80 and 89?
Yes.
So then at this point, we found a match. Having that match, I go ahead and display the name, the score, and then the grade, which in this case is a B. And then I go ahead and do the same thing with the other columns, so the other rows. I don't find a match there, I don't find a match there, so then I go to the next row. And so then this one matches up with that. And then I display a Scott 73 C. And so notice that it's scored between that range. And notice that I'm not using any table prefixes because all the column names are very different. That's a non-equi joint. It's still a joint.
It's like a VLOOKUP.
What was that?
It's like a VLOOKUp in Excel.
It's like a VLOOKUP, that's right. Okay, so now this is kind of interesting. It's interesting in the sense that you're able to go ahead and get to the point that you want, not through a single step, but through multiple steps. So look at this. We have a whole bunch of people. They are taking a bunch of different classes. So that's what we have. And what we're looking to do is we're trying to go in and come up with a look that looks like this. So this is the actual stuff that is sitting inside the table. And you notice that the people were taking philosophy 1, 2, 3. So at the end, I can see them, that there are 3 people. Here I have 1, 2, and here I have 1, 2, 3, 4. So it doesn't look like we're actually applying a group function, because a group function will actually go and collapse it. If I were just saying, like, how many people are taking philosophy, we would collapse all these 3 rows into a single row philosophy, and then come back with another 3. But in this scenario, we want to go ahead and just sort of have a count to find out how many people we have here, how many people we have there. We're looking for this kind of visual. So the question is, how do we actually accomplish this? Well, how about we do this? I'm going to go ahead and display the name of the class from the student table. So this is all the name of the class. And then there's this row num that we have. And what happens is when you go ahead and do this, row num is a pseudo-column that's a num to a symbol. And so all the rows, they have this row num associated with them. And so you notice that we have 1 through 9, okay? And so it just moves up in sequence. And by the way, if you go ahead and remove, let's say, one of these rows, well, there's a gap. So we have row number 7 and we have row number 9. There's nothing to the left for 8. That's just how it works. Okay, so we have it. You can actually go ahead and display it as we are right now. Now, row num is not a column that I created. It's once again a pseudo column that's available with every table that you create. Okay, so we have that. And notice that what I do is I go and feed those results into a table called temp1. So all of this now is sitting in the table temp1. Then I go ahead and create another table called temp2. And I say, why don't you go ahead and go to this table student. And I want you to go ahead and group by class. So there are 3 different classes: science, religion, and philosophy. And it just so happens that when you take a look at these ones, when you take a look at the row number on this one, you notice that we have 1 is the starting point for the philosophy. 4 is the starting point for religion, and 6 is the starting point for science, right? Those are the row numbers that are the starting point for each of the categories. So what I do is I say, hey, you know what? Go to the student table, and why don't you go and pick the minimum row number for each of the different classes. And so what I come back with is all of these different row numbers, okay, for the different classes. And by the way, notice it says minimum, okay? So whichever one is the smallest one. So given this grouping, which one of these row numbers is the smallest one? Well, it's 1. Which one of these is the smallest one? Well, it's 4. So that's what we have. So at this point then I have 2 tables. Here I have tab 1, which has all of this information. I have tab 2, which has this information. Now, what can I do with this? Well, what happens if I go ahead and bring these 2 tables together, and then I go ahead and do something with the row numbers, which is to go ahead and take 6, subtract it from 6, and then add 1 to it. 7, subtract it from 6, and add 1 to it. What happens? Then I can get 1, 2, 3. I can do the same thing with this one. Take 4, subtract it from this 4, and then add 1 to it. And so I get a 1, and then this one becomes a 2. And then the same thing is true with this. I get a 1, 2, 3, if I'm able to go through line this 2. And that's exactly what I've done. I say, you know what, I have a temp 1 and I have a temp 2. So there it is. And I'm going to go ahead and lock these 2 tables in based on the actual classes up. So all of these sciences are going to be tied to this one right here. So notice temp 1 class to temp 2 class. And I'm doing some ordering here as well, just so that I can display things. But then I go and take the line number in temp 1, subtract it from this line number from this one right here, and I add 1 to it. And so what I'm left with is this thing right here. Now the reason why I'm showing you this is just to go and indicate that you will not necessarily be able to go and arrive at your results using a single SQL statement. Sometimes you can just go ahead and feed things into these temporary tables and bring them together, as I did in this case. Okay. All right, so let's go ahead and find out how we go ahead and do this. Okay, so display all the people and all the potential personality types that they can have. And display name and the personality description. Okay, so what do you think? So let's just go ahead and so here once again we have the person's table. What's it going on? Okay, so we have like John has got personality 1, and Chin has got personality, let's say 2. And so we say 1 is good, 2 is bad, 3 is ugly. Okay, so we have that. Now it says, why don't you go ahead and go with this crossroad. So how would I do it? To see all the people with all the different potential personality types they could have. So what would that syntax look like?
Select name, description from person, cross-join personality.
So description. And so from person, and then personality. Well, that would
Cross-joining personality.
okay. Now, so this would be the Cartesian product, okay? So that's one way of doing it. We could actually go ahead and cross join in here as well, and that would actually going to give us the same exact result, right? So if you don't actually put a join condition, that becomes the exact same thing as a cross join. Okay, what about this one? Display the name and personality description of all those people who have a personality. Okay, so what do you think? So let's go ahead and add this other person here as well. Jim. So display the name and the personality description of all the people who have a personality. So what do I put here? So this would be John is good and Jim is bad.
Select name, description from person.
Okay.
Where that person or personality ID is not null.
Why, do you like that? So he's saying that, let's go ahead and just say where we have her ID is not, or her ID is not null. Is that what you have in mind? Okay, do you like that? Do you think that's going to give us what we're looking for? So keep in mind, what we're looking for is going to display John is good and Jim is bad. So that's one suggestion. What other suggestions do you have for us? Yeah, you have it. Do we what?
Initial join?
In,
Initial join?
initial join, or inner join?
Initial.
Natural.
Oh, natural join. Oh, okay. So what do you have in mind? Give me the syntax.
Select name, description from person.
Select name, description from person,
Initial join, natural join,
natural join,
personality.
personality. Okay, do you like that? That seems to make a little bit more sense. Why? Well, let's go ahead and just come up with another syntax instead of natural join. So let's go ahead and just go with using the same thing, but let's go ahead and use the word clause. From person P, personality PER, okay? And then, what do I put?
Where P, personality,
Okay, let's just make that P.ID equals to PR.ID. Yes? Okay. Now, you notice that there is no mention of null. Is that a problem? That's not a problem. Because what it's looking for is the stuff that's common. And notice that we're using this equal sign. And the equal sign is always going to go in and take a look at places where there's data. So in this case, this thing will never equate or will never match anything on this side. So it just is completely ignored. So does one match up with the one here? Yes, it does. So then we have John and display good. Does Jim match up with anything here? This 2. Yes, it matches up with that. So it's going to be Jim and that. Does Jill match up with anything here? No, well, Jill, if this one is a null, so we don't worry about it. And so a natural join, or this one right here, the syntax, that always. Okay. Now, let's go ahead and take a look at this thing called stop join. Now, imagine as if we have this table called employee. And you notice something interesting about employee. Employees, well, they have SSNs, they have names, and they actually have people that they report to. They have supervisors. And supervisors, of course, they have their own SSNs. And the employees also need some salary. So, really, when you look at it, what is going on here is you have this employee Jack, and his manager is 222. But who the heck is 222? 222 is Joe. And his ID is 999. Now, who the hell is 999? Well, no one, so I guess he's the boss, okay? What about this one right here? John is 222, okay, as well. Now, Jill is 111, and so 111 is right there, and then Jack, and then his manager is 222, which of course we get to this guy, Jill, right here. So, you notice that we can go ahead and in this one table, we can go ahead and find out the fact that Jack reports to Joe. right? It's all embedded in it. But the problem is right now, when we go and display this information, we can only go and see the social security number of the manager. We'd like to go and see that Jack is reporting to Joe, for example, and that Jill is reporting to Jack. We'd like to see those names. So how do we actually go and do this? How about if I go in and just say, you know what, I have an employee table, and I'm going to go in and come up with a name that's called E. But then I'm going to go in and say that I have the employee table again. I repeat that. And then I go in and associate it with that. So in essence, really what I'm doing is it's kind of like I'm dealing with two different tables. Here's one table. Here's another table. This table is what we refer to as E. The other one is M. Now, the fact that it's the same table, you shouldn't be bothered by that. At this point, you can just go ahead and treat it as if we're looking at two different tables. And then you go ahead and just do the matchup. So at this point, what do I want to do? I want to go ahead and match up the manager in here with the SSN in here. So I come over here, I match that up, the manager SSN with the actual SSN here. And so that's what I come up with. Now that I have that, I can go and say, hey, let's go ahead and display the E name, and let's also go ahead and display the M name. So that will give me the Jack and the Jill that I'm looking for. Yeah? Okay. So that's what we have. And it's just more of the same stuff. Okay. So that is the inner join. Now let's go ahead and talk about the outer join. You know, I think the one area in Oracle where people get confused is outer join. So, you know, if you take it, you know, like C programming, you know, the one area that people get confused in C programming is pointers, because it becomes a little convoluted. It just so happens that with the outer join, this is the one area that becomes a little convoluted as well. As a matter of fact, if you're actually working out there in the world databases, you'll find that people, when they're actually doing this outer join stuff, they guess a great deal. Just like when people are working with pointers, they guess a great deal as well. So it's very important that you understand what's going on with this outer join stuff. So imagine as if we have two tables. Right? Whatever this is, who cares? Okay? So apparently the outer join is saying that give me the stuff that is common between the two tables. In addition, give me the stuff that is in one table but not in the other. Now, this Venn diagram is kind of incomplete, okay? Because when you look at this, it appears as if, well, let's just grab everything from the second table, right? Why do we even need to go and include the first table? So this is not really an accurate depiction of what is going on with an outer join. But so the actual description that you want to keep in mind is that an outer join is first and foremost an inner join. Then you go and add more additional data to the inner join by bringing in all the stuff that is in this table, but not in this table. Now, when you're looking at this table, you notice that one table is sitting on the left-hand side, another table is sitting on the right-hand side. Yes? So if you were to go ahead and look at this, okay, this kind of picture that we want is referred to as a right outer join. Why is it right? Because the table that is sitting on my right-hand side is the table that contains stuff that is sitting inside of it, but not in the inner table. You take a look at this one. Oh, these are exactly the same. Okay, so imagine for a moment that what we wanted to have here was this. And let's just say that this was white. Well, actually, let's just do it like this. So imagine as if this is what I wanted. So this is table 1, this is table 2. As you look at this, you notice that, once again, we have the inner join that is actually happening, plus all the stuff that is sitting on the left-hand side that is not on the right-hand side. So this one right here would be the left outer join. So this picture that I stole from someplace is not good. That's a bad picture. So this only goes to show you that plagiarism does not always pay. Okay. All right, so that is what is going on. Now let's go ahead and find out if the stuff that I have here can make a little bit more sense. So in this case, you notice that in this table, we have this 5 in column B that's not matching up with anything in this table. There's no 5. And then of course in this one, there's that 4 that's not matching up with anything there. So let's go ahead and do a left outer joint. So a left outer joint would be this one right here, which means why don't you go in, so let's go and call this like table 1, and this one right here is table 2. And so notice that table 1 is on my left-hand side. And so we're going to go ahead and first and foremost do an inner joint. The inner joint would actually go ahead and give me all those different roots, which is the 1, 2, 3 commonality that I see it. And then what happens is the outer joint is going to go ahead and give me this additional row, which is this one right here, the 5 that's not matching up with anything. Now, meaning that at this point, you notice that I'm displaying column A, column B, column C, column D, column E, column F. Because the 5 is not matching up with anything on this side, well, what do I put for column B, column E, column F? Well, since it didn't find a match, it's going to go and just put a bunch of rows in there as fillers. Now, if you were to go into right outer joint, okay? Well, at this point, our focus becomes that 4 right there. So I go and do that inner joint, which captures the 1, 2, 3 that is in both tables. And then the 4. Well, I have the DDD, 4, EE, FF, so I have all of that along with the 4. But what do I put down for column C and column A? Because that 4 is not matching up with anything in here. Well, I just go with the notes. But it's still a row that I go with. Now, at this point, you may be asking yourself, why would I even care about the proper joint? What kind of results is this? We'll come to find out in just a moment, okay? Now, is there anyone who didn't understand what I just discussed here with the left and the right outer joint? Yes?
So is it basically the same left and right joint?
Say what?
Is it basically the same as left or right joint?
Yeah, so, you know, they usually, you know, just to go ahead and abbreviate this, they don't say left outer or right outer, they just say left joint or right joint. It's the same thing. Okay, so let's go ahead and take a look at this. You know, we have 3 tables. So there's that. These are the 3 tables. And let me go ahead and split the screen. Okay. So let's go ahead and find out what happens with this. Now, in this scenario, what we do is we're going to go ahead and look at A, B, and C. So all those 3 tables. And then I say, well, column 1 equals to column 2, and column 2 equals to column 3. Okay? So let's see here. Where column 1 equals to column 2. Does A match up with anything in this other table, column 2? No, it doesn't, right? So then if that's the case, we abandon this. What about this one? Does AB match up with anything? Yes, it does. It matches up with that. And then that AB doesn't match up with anything. Because column 2 is supposed to go and match up with column 1. No, so we abandon that as well. What about AC? Does it match up with anything? No, so we abandon it. What about ABC? Does it match up with anything? Yes. And does ABC, does it match up with anything here? Yes. So that's why we're getting the result here. So this is an example of an energy in which we're looking at the commonalities from all tables. Okay. Now, let's go ahead and just see what's going on. Now, you notice that we're introducing this interesting syntax called plus, okay? Now, this plus, from this point on forward, whenever you see the plus, just think about the following. I don't really care. So plus means I don't care. And whenever you don't care, you're going to just put a null there. Okay, that's what that means. So let's find it. A, B, and C. That's what you have. Now, you notice that, of course, we are referring to column 1, column 2, and column 3. So the columns from all these tables are included, which means that we're not looking at any kind of a Cartesian product, any kind of a cross joint, because we're attempting to connect all these together. Okay, so that's one. Now, so so in this case, does column 1 match up with anything? No. But then notice it says, you know what, if you don't find a match, who cares? I don't care. And when you don't care, you just go ahead and put a null. Now, we're not actually inserting the null into the table. This is only happening all just, virtually in our own head, okay? So at this point, what we have here is an A here and a null here. And then, column 2, does it equal to anything in here? Well, does null match up with anything in here? No, it isn't. Well, let me ask you a question. If I actually had inside of this other table an actual null, would it then match up? So I would actually have A here. I would have null here. A here. Then A here. And then null here. Okay, you got it. And then, does column 2 equal to column 3? Does null equal to null?
No.
The answer is no. Because what is null? It's a void of data. There is no data. And do you actually go ahead and match up against null using the equal sign? No, you're going to use the is keyword, right? We're not using the is keyword. So this will never actually find a match. So at this point, this fails. What about AB? Well, AB, does it equal to anything in column 2? Yes. So at this point, we didn't need to use the plus sign. And then column 2, does AB equal to anything in here? And the answer, of course, is no. So we skip that as well. What about AC? Does it match up with anything in here? No. But then, who cares? That's that plus. Then null, does it match up with anything in here? No. So then we abandon that. And so notice that we actually go ahead and come up with the same result. ABC matches up with ABC, which matches up, of course, with ABC. So you're thinking all of that, and we came back with the same result. That feels like such a waste, okay? But this is only to go ahead and just indicate to you the mechanics of how the plus sign works. Let's go ahead and find out a little more. Okay, so this makes it a little more interesting. All right, so notice that once again, we are including all columns, column 1, column 2, column 3, so there is no Cartesian product. And so we go ahead and take this column 1, which is A, and does it match up with anything in here? Well, no, so we have a null. And then it's trying to go ahead and connect column 1 with column 3. Do we find a match between A and anything in here? No, so we abandon this. We go with AB. Does AB match up with anything in here? Excuse me. All right. So AB matches up with that AB, but then column 1 is equal to anything in column 3. Does AB match up with anything in here? No, it doesn't. So we abandon that as well. Let's go with AC. Does AC match up with anything in here? No. But the plus says that I don't really care. So this means that we did that. Right? And then it says column 1 equals column 3. Does AC match up with anything in here? Yes. And that's why we get AC. No, AC. And then you notice that we still get our ABC, ABC, ABC. So this thing right here that we're using is used for outer joint. And remember that an outer joint is first and foremost an inner joint. In every single instance, we're getting the ABC, ABC, ABC. The question is, do we want to go and get some additional data? Now, as you're looking at this additional data looks meaningless to you, okay? And that's okay, because I haven't really come up with anything that's interesting. We'll do just a few moments. Let's go with this. In this one, once again, we have ABC. Does column, okay, column 1 equals to column 3. So, does A match up with anything in here? No. But do we care? No. There it is. And then it says column 1 does it equal to anything in column 2. No, it doesn't. So we abandon it. What about AB? AB, does it match up with anything in here? In column 3. So notice column 1 with column 3. The answer is no. So then do we care? No. And then does column 1 equal to anything in column 2? Yes. We find it. And so that's where we get the AB, AB, and then the no. Then we go with the AC. Does AC match up with anything in here? The answer is yes. And then does column 1 equal to column 2, anything in here? No. And so we abandon that. And of course the ABC matches up, which means that it's first and foremost an inner joint, and then we actually put these additional rows in there as well. Okay, so there is that. Now, let's go ahead and take a look at this. This one. Column 2 equals to column 3. Column 2 equals to column 3. Immediately when you're looking at that, what is the first thing that comes to you when you're looking at this? What is the first issue that comes up? What's that?
There's no column 1.
There's no column 1. And so when there's no column 1 means that this means there's some Cartesian product thing that's going to happen, right? So whatever answer we come up with is going to be Cartesian producted with everything in here. So we'll actually have 4 of that one row that we actually matched up against. So that's one. The other thing that we actually going to see is that this plus sign, does this plus sign even mean anything in this context?
No.
No, because in the one scenario it says, hey, you know what, column 2 and column 3, let's find a match. But if you don't find a match, who cares? But then you turn around and you say, you know what, I really do care. This is kind of like us human beings. We can't really make up our mind, right? So at this point, this thing is confused. Do you care or do you not care? And so at this point, then we're going to have to go and say that it's really looking to go ahead and match up column 2 and column 3. So does B match up with anything in here? No. Does AB match up with anything in here? No. Does BC match up with anything in here? Yes, it does. So we find a match between this BC and this BC. But notice that column 1 was not included, so it's going to go ahead and have A, B, C, B, C, A, B, B, C, B, C, A, C, B, C, B, C, A, B, C, B, C, B, C. Okay? And then, of course, we continue on. We have ABC, that's the Cartesian product. Okay? So we have ABC and ABC, that matches up. And then once again, we have A, ABC, ABC, A, B, ABC, ABC. Because once again, we're not trying to match up anything from this table. And so that's where the Cartesian product comes in. And so when you go ahead and take a look at this, look at that. You're seeing the BC and the ABC being Cartesian product. So make sure that you include the columns from all the tables that are included in your joint conditions. Okay, so let's go ahead and see this one right here. Now you notice that we have a plus sign here and we have a plus sign here. Let's see what happens when we do it this way. So, A. Does it match up with anything in here? No. But then it says we don't really care. Right? That's where you get the no. Then, it says column 1. What is column 1? A. Does it match up with anything in here? No. But does it care? No. Because of, once again, that plus sign. So at this point I get A, no, no. Then I come over here. Does AB match up with anything in here? Yes, it does. Then, does AB match up with anything in here? No. But then that plus sign says I don't really care. So there it is. Then AC, does it match up with anything in here? No, but we don't really care. And does AC match up with anything in here? Yes, it does. That's why we get AC, null, AC. And then, of course, we get to ABC, and so then we see that. So notice that it's first and foremost an inner join, and then we get these additional ones. And notice that the only way that you can go ahead and figure this out is if you just manually go through all these things to make sure that you don't miss anything. So what about this one right here? Now this one, it appears as if we're doing the same thing, but when you go and compare the two, you notice it's a little different. In this one, we're connecting column 1 to column 2, and then column 1 to column 3. But in here, it's column 1 to column 2, and column 2 to column 3. So this part of it is different. Now, what exactly does that mean? Well, let's go ahead and find out. Does A match up with anything in here? No, so then we don't really care. And null, because that's column 2. Does it match up with anything in here? No. But then do we care? No. So notice at this point that this plus sign allows me to go ahead and pass the null through the system as well. You see, if I didn't have this plus sign, if I didn't have that, the null would never equate to anything in here, because a null cannot be matched in that way. But because of this plus sign, since we don't find a match, this says, I don't really care. And so you're able to go and just allow the null to travel through. Yes?
Wouldn't you have to add a plus, for the second statement on the right side of column 2? So wouldn't you have to add another, yeah, like right there?
A plus sign here?
Yeah, or just putting the plus at the end of it, just.
Well, so let's go ahead and find out what plus means. Plus means, I don't really care.
For the whole comparison,
Okay,
not just.
so if you want to go ahead and just put a plus here, okay? What is going on is, this is saying, I don't really care. This one is saying, I don't really care. You can't have just a bunch of people not caring about everything. That's why you have war, okay? So we need somebody to care. And so we're saying either the left-hand side or the right-hand side, one of you needs to care, which means you need to have some data that you're looking at. And then, of course, if you don't find a match, that's fine. Okay, just let it go through. But we need to be looking at some kind of data. Now that data, it could be a null that we've actually sort of allowed for it to pass through. So when you're using the plus sign, you can't have a plus on both sides. That's what. And that's what I indicate right there. You cannot go ahead and put it on both sides. Because if you do that, then Oracle will say, yeah, equal balance this. Okay? All right, so then let's go ahead and just look at this in the context of patients and diseases. Okay. Now, this one, we have patient disease, and we have disease. We have all those 3 tables. So we're hoping that we're connecting all these 3 tables in some way, shape, or form. Well, are we? We have patient ID in the P table, patient ID in the PE table. And then we have the disease ID along with the disease ID in both of these tables. So it looks like everything is being connected. So that's great. Then what we have here is, so let's go ahead and take a look at this. At this point, we're looking at John. Does 111 match up with anything in here? Yes, we do find a match. There's that red line. We find a match with that. And then we come over here. Does this 11 match up with anything in here? Yes, we do find a match. So we get that whole entire row that is in red. So we can go and pick and choose what we want to go and display, which of course in this scenario is John Doe, and the disease would be cancer. But then we have another one, John Doe, that 11 right there, is also matching match things up. And so that's the inner joint stuff. So notice in this case, with the inner joint stuff, somebody like Billy Bob gets left out, right? Because 114 doesn't get matched up with anything. And also you notice that the fluid, that gets missed out as well. Because there is no one who actually has the common fluid. So the outer joint will actually allow us to go and capture those additional pieces of information into our result set. So let's go and see what happens. Now, what I've done here is, actually, I should call it this. Okay. You notice what I've done is to go ahead and put these pluses on the tables that we don't really care about. So notice that we have the PD table, which is the patient disease table. That is a plus. And then we have the disease table. That is a plus. So actually it's this one right here. Okay, it's this one right here. So the disease table has a plus, and the patient disease has a plus. So what is the net result of that? Well, we said that an outer joint is first and foremost an inner joint. So we get all this common stuff that we're looking at, which is John Doe had cancer, John Doe malaria, and then Jill Crane also has cancer. But then what happens is, let's go and take a look and see what happens to Billy Bob. 114, does it match up with anything? No. That patient ID does not match up. But then do we care? No. If we don't care, then we go and create an entire null row. It's not that once again we are inserting it. It's just there for whatever it is that we're doing right now. Then at this point it says, hey, you got a disease ID? Yes, I got a disease ID. It's null right now. And it says, match it up with a disease ID here. Do I find a match? Well, even if there is a null, it doesn't find a match. But once again, it says, I don't really care. So when you don't really care, you have a bunch of nulls in there as well. So then we get 114, Billy Bob, null, 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 null. So that allows us to go ahead and bring Billy Bob into the mix as well. Now, when you go in and take a look at this one, notice that we're actually associating the plus with the patient and the patient disease. So look at that, with the patient P and the patient disease. There it is. What does that mean? What that means is that you can actually go ahead and once again get that inner joint. So you get that inner joint right there. So you capture all the common stuff. But then, what happens here? 3, 3. Does it match up with anything in here? No. But then what happens is it says, you know what? If you don't actually find any disease ID in the patient disease table, who cares? So this 3, 3, I don't find a match with anything in here, but I don't really care. So it creates a bunch of nulls. And then this one says, you know what? You got a patient ID. Well, that's a null. Do you find a match for it in here? Well, it doesn't. But then this one says, you know what? I don't really care. And so as a result, we have all those nulls. And so it actually allows for the flu 3, 3 to also be included in the mix. So in this scenario right here, we get to go in and see Billy Bob. What the hell? Okay. So in this case, we get to see Billy Bob. In this other one, we get to go and see the flu. Along with all the inner joint stuff. And that's because of these pluses. So the pluses are saying that we don't need to care. That's what it's saying. Are you with me on this? Okay. So you're thinking it would be nice to actually go and sort of test out your understanding of this stuff. And we will in just a few moments, okay? So, Now, take a look at this. We have patient, disease, and disease. What is the problem with this?
You're only
Only
linking two tables.
linking two tables, which means that the disease table is actually going to go in sort of the Cartesian product. Which means that every row that we come back with, it's going to go in and have 3 iterations of it. One for each of the rows of the disease table, because we're not including the disease table for this. So in this case, we have patient ID 11, it's matching up with that. And so we're going to go and repeat that 3 times. Then we get 11 again, matching up with this one. We're going to go and see that 3 times. Then we see 114, it's not matching up with anything, but then we don't really care. And so we're going to go and repeat that 3 times. And then 113, once again, we match that up, and we're going to go and see that 3 times. So when we do that, you notice that we see all those iterations to indicate that you need to make sure that you include all the tables. Now, what about this one right here? And this one, well, oh, okay. Now, this one is kind of interesting. You notice that in this case, we only have 1 plus sign. We don't have 2. So what does that mean? Well, we have the disease ID equal to disease ID. So we know that first and foremost it's an integer, so we get all that common stuff. The question is, do we get that 3 or that building block? So disease ID, well, actually, let's go with this one. Well, yeah. So disease ID, does it equal to anything in here? No, it doesn't. But then you notice that at this point it doesn't, and so we just go ahead and ignore it altogether. So the 3 is not going to be included in any of this. Now, what about this 114? 114 doesn't match up with anything in here. Well, it doesn't. But notice that there is no plus sign in the patient disease, so that's not going to be included either. So you need to make sure that you know exactly where you want to go with the plus sign. Now, it just so happens that if you don't like plus signs, Oracle provides for you the syntax that you can use. And the syntax goes as such. You have the disease table, you have the patient disease table. And you notice that this syntax right here, you have the disease table sitting on this left-hand side. And you have the patient disease sitting on this right-hand side. So it says, let's go into a left triangle. And the left means let's go and place the emphasis on the table that is sitting on the left-hand side of that syntax right there. So that syntax. So this syntax, this is the left-hand side, that's the right-hand side. So we're going to go ahead and include everything from here. So it says the disease and patient disease. So we are interested in only these 2 tables right here. Those tables. Disease and patient disease. And so first and foremost, it's an integer. So we get the 1, 1 along with the 1, 1, and the 2, 2 along with the 2, 2, and the 1, 1 along with that 1, 1. And then this 3, 3 though, we don't actually go ahead and find a match. But then, because we have the emphasis on the disease, it says, you know what, we'd like you to go ahead and include everything from the left-hand side, which means include everything from the disease table. So the 3, 3 will be included. So the thing that you need to go and keep in mind, and this is the part that becomes confusing, you know, when we actually have, let's say, table 1 and table 2, if I were to go ahead and put a plus right here, it means that I want to go ahead and include, you know, let's just say that we have that, and let's just say that we have that, for this example. So it's going to go ahead and do the matches, and then wherever it doesn't find a match, in this case, it says I don't really care, and so it's going to go to display that. Now, if you didn't want to use the plus plus syntax, if you want to go ahead and come up with that same answer, let's just actually go into this as well. If you want to go and come up with that same answer using this other syntax, you need to go ahead and put left outer join. Notice T1 is on the left-hand side of that syntax. And so that's saying, let's go ahead and include everything. Once again, you get that, and you get that. So we're, in this case, using that syntax, is saying, put the emphasis on this table. In the left outer join, the left means put the emphasis on this table. So just keep that in mind. It's kind of like the opposite of one another, okay? So the plus says the other one. The left is telling you which one to go ahead and put the emphasis on. Hopefully I haven't confused you. Or I would, yeah. So what about this one right here? So this one, patient disease, right outer join disease. Now notice that this is exactly the same syntax as the one above. It's saying, why don't you go ahead and just place the emphasis on the right-hand side of the syntax, which is what? The disease statement, which says, I want you to go ahead and include the flu into the mix, because the disease table that disease table is on the right-hand side of that syntax itself. So it's first and foremost an inner join. Then you go ahead and bring in all the stuff that is sitting on the right-hand side, which you haven't been able to go and find an actual in here. So my question to you would be the following. If I have this table 1, and we have a table 2. And let's just say that we have 1, 1, and then we have 2. So let's just go ahead and call this column. Let's call this column. So I go and say from T1, T2, where? And I'm going to go ahead and say where T1 dot column equals to T2 dot column. Now, where does it make sense for me to go ahead and place the plus in this scenario? T1. So I need to go ahead and put the plus right over here, because this 2 will not match up with anything in here, right? And I want to go ahead and include that, so I want to go ahead and put that in. So if you go ahead and put the plus on this 2, what happens in that scenario? You just get back to 1, right? So the plus is actually wasted, right? We don't get anything because we say, hey, you know what? Let's go ahead and match up those 2. That's great. And then there's nothing else. Let's just say, yeah, so there's nothing else for us to go and include. And so that plus doesn't mean anything. Now, if you go ahead and take a look at this right here, the patient disease. If you're looking at these 2 tables, just those 2 by itself, does it make any sense for us to go ahead and associate the plus sign with the patient disease table? No, right? Why? Because you see, the patient disease table is the association table. It's supposed to have all the IDs that have been defined in the parent table, right? So I cannot have some like a disease ID like 19 in here, because 19 has not been defined. So all these IDs are defined in here. But it is very possible for me to go and have an ID in here that's not defined in here. That is patients who actually still haven't gotten that same disease. Okay, so if I have a disease like 19, it's very possible that there are some patients that don't have, or there are patients that don't have disease 19. So just keep that in mind when you're looking at these things. let's go and take a look at this. Now, in this case, you notice we have a disease table, we have the patient disease table. Notice that the emphasis is on disease. And then we also have this patient. Now, at this point, this looks a little confusing, okay? So let's go in and see if we can decipher this. So, what is going on is we have disease, and there's a left outer joint with patient disease. And then it appears as if, and then this on disease ID equals to PD disease ID, it's just identifying what columns in the disease table you want to go in and just connect to the patient disease. And then it appears as if there's another left outer joint with the patient table. Okay, so that's what we have. So this is the disease, left outer joint with patient disease, left outer joint with patient. Now exactly what does that mean? You know, let me ask you one question. When you have 1 plus 2 plus 3, when you have these numbers, how do you actually go into the addition? Well, aside from that, do you go ahead and add all 3 of them at the same time? You add 2 at a time, don't you? So you're going to say, what is 1 plus 2?
3.
3. And what is 3 plus 3? 6. So you're adding 2 numbers at a time. Well, in this case, when you're wanting to go and use this left outer joint syntax, what occurs is you're going to go in and just do a left outer joint with that. This will give you some kind of a result set. Then you will go ahead and take that result set and you will do a left outer joint with that. Okay, so that's how that works. And so, in this case, when you do a left outer joint, you're placing the emphasis on the disease, which is to say that find the common stuff, and then give me the orphan records for which you cannot find a match for, which means that you actually go ahead and get the 3-3 flu. Yes? Because the flu's not matching up to anything. Along with everything else. Then we're going to go ahead and take 3-3 flu along with, 1-1 cancer and 2-2 malaria, and then 1-1 cancer. So we have all of those. And we're supposed to go ahead and match, and so also I guess we should go ahead and identify the patient IDs. So this one is patient ID 111, this is patient ID 111, that's patient ID 113, and this one is me. So when I go ahead and do a left outer joint on these 2 tables, this is the result set that I get. Then it says, why don't you go ahead and take that result set into a left outer joint with patient, which means why don't you go ahead and just place the emphasis on this table. So first and foremost, 1-1 matches up with the 1-1 there. So that's going to be included. So we get 1-1, 1-1 cancer, 1-1 job bill. Then we get 1-1-1, 2-2. So once again, we deal with John Doe again. Then we have 1-1-3 Jill Crane. But then we have this 3-3 flu. Well, its patient ID is known, but we don't really care because it's a left outer joint, and we want to go ahead and include that in the mix. So in this scenario, what will occur is we'll actually go ahead and have all the inner joint stuff along with the 3-3 flu in there as well. So if you take a look at this, look at that. You get all of that along with the flu in there as well. All right, so let's go ahead and just stop at this point. Let me go ahead and share with you maybe some slides. Okay, so now that I want to do this, I'm coming up, let's go over here. And remove assignments. And so let's go ahead and find that. What is going on? So display the Cartesian product. Last name, party description of each individual. Last name, so this is all movable. Display the number of people. Okay, so this is good. So this is something that you can go ahead and work on. I'll make that available. And then the other one is also other children. So this is something that there's a party associated. Okay, so we can go and work on the slope zone. Yes? No? Any questions? So those two would be available to you for a month. And so let me know if any questions come up. All right, thank you.